The next bridges that we're looking at are pretty generic, and this is what I was expecting from AliExpress for this $60 price point. I spent a few bucks more to get the 5 GHz unit, but it was close to the same price as the Tenda set for 2 of them. There's no real brand listed anywhere. The box has wireless network surveillance solutions and professional quality trustworthy printed on it. The listing called it a 9344 chipset Wi-Fi router, Wi-Fi repeater, long range 300 megabits, 5.8 gigahertz outdoor AP CPE, AP bridge client Wi-Fi router, and the unit itself had 8881CS02B on the circuit board. The build quality is pretty bad, with the plastic feeling pretty thin and the port door not fitting well. The cable holes on the door also don't line up with the network port at all, nor do any of the perforations. They can be easily popped out. Moving to the back, the mount is a similar fixed design as the Tenda. The status LEDs have no light pipes and just blast light through the back of the thin plastic case, which could make it look like an obnoxious lantern at night. As far as accessories, it came with a PoE injector with a non-North American plug, which was my bad for not looking at it closely in the ad, but it can work with a simple adapter since it does support down to 100 volts AC. The issue aside, the PoE injector outputs 24 volts, so it shouldn't have the same issues as the Tenda with long cable runs, and it will work with commonly available passive 24 volt PoE injectors and switches for Ubiquiti, Microtik, and other similar vendors. The other included accessory is a couple white zip ties for mounting it to a pole. These are trash and will probably get brittle and snap after a while of being exposed to UV from the sun. After it does that, it'll probably hang upside down where it'll fill with rainwater and die, so you'll probably want to use something better to mount it, like hose clamps or actual UV rated zip ties. After tearing it apart, I found that this unit has a single polarity antenna when all the other bridges are dual polarity. This halves the amount of possible speed and channel efficiency of the bridge compared to the others. That said, you'll probably run into a bottleneck with the 100 megabit Ethernet port, depending on the size of the channel used. The main SoC is some sort of Qualcomm chipset going by the AliExpress listing, but there's a heatsink covering it, and it's attached with some strong thermal adhesive that I'm afraid to rip off. Whatever it is, it does support the 802.11ac standard, which is pretty nice for this price point. To set these up, I'm going to start by powering these using some Microtik PoE injectors, since I don't have the adapters to use the included injectors with a North American outlet. Going off the all-Chinese booklet, I found the default IP for these to be 192.168.0.1, so I set my computer to a static IP address of 192.168.0.5. I opened up a web browser, navigated to the 192.168.0.1 IP address, and I logged in with a password of admin. You can go to the quick setup, and for the first device I'll set it up in master mode. So I'll select it and click next. On this page I'll leave the IP alone, but I'll set up an SSID and password, drop the channel bandwidth down to 40 MHz since we can't take advantage of the 80 MHz wide channel anyway, set the channel to auto and then click next. We'll wait for it to reboot and then log back in. Then go into the wireless basic settings and change the region to USA, which is as close as I'm going to get. Then I'll click apply. We'll leave this one powered on, then we can plug in the second bridge into the laptop. We're going to access it from the same 192.168.0.1 address. This time we'll go into the quick setup and set it up in slave mode. This page will do a quick scan for Wi-Fi networks, and we'll click on the one that we just set up. Enter in the wireless password you set up before in the repeater password box and click next. On this page I'll change the IP address to .2 so there isn't an IP address conflict. And we'll change this to our home network IP address after we confirm everything is working. After we wait for it to reboot, we can try accessing it with its new IP address, then log back in. We can check that it's connected and showing the signal strength, and we can log into the AP side of the bridge at 192.168.0.1. Then from the network settings, we can change the IP to fit our home network. We'll then go back to the client side and put in the other IP address for our home network. I'll plug the AP side of the bridge into my home router. Then I'll go back to my computer's Ethernet settings, then change back to getting an IP automatically. In a moment, I should be able to access both bridges by their IP address and also access the internet. To test this bridge out, I set them up in my basement just under 40 feet apart with a laptop running the iPerf 3 test on each side. The signal isn't coming in as strongly as I would expect for being this close, but despite that, I'm seeing this thing max out the 100 megabit Ethernet port. I ran Ping Tracer for a couple minutes at 5 pings per second, and the average latency is 1 millisecond with no drops during the test. For the power consumption test, the AP side of the bridge is idling at 1.2 watts, and that goes up to 2.2 watts when running a test. For being the cheapest 5 GHz bridge I could find, I was surprised that you could get enough wireless performance to max out the 100 megabit network port with low latency and low power consumption. I expect the wireless chip being 802.11 AC really helps with this. Despite that, there's still quite a few downsides to this product. As I expected, the build quality included accessories aren't great. Considering how generic the thing is, I wouldn't expect any firmware updates or support from the manufacturer, whoever that is. The signal level I was getting at 40 feet wasn't bad, but I expect the combination of antenna gain and transmit power isn't very good, so you probably won't be able to go too far, and any obstructions will really hurt the link. At this price point, long-term reliability is also unknown. So I probably wouldn't recommend this one, but at least it shows that cheap doesn't have to mean slow, but you are compromising on other aspects of the device.